Imagine, if you will, standing on the edge of a scientific mystery, armed only with a question and a set of data. Can you determine the truth? Welcome to the world of hypothesis testing, the cornerstone of inferential statistics and scientific research. Picture the process as a courtroom trial. The hypothesis under investigation is like the defendant waiting to be proved innocent or guilty, but instead of a jury, you have data and statistical analysis to help you make the decision. The first step in this process is stating the hypotheses. In our courtroom analogy, this is akin to the charges being read. The null hypothesis, typically denoted as H0, represents a statement of no effect or no difference. It's the status quo. The alternative hypothesis, denoted as HA or H1, represents a statement of an effect or difference. It's the claim we're testing against the status quo. The second step involves deciding the significance level, often denoted by alpha. Think of it as the burden of proof. Commonly set at 5%, it defines the probability of rejecting the null hypothesis when it is true. It's the risk we're willing to take of making a wrong decision. Next, we collect and analyze the data. This is the investigation phase, where we gather evidence to support or refute the hypothesis. We calculate the test statistic, a measure that helps us decide between the null and alternative hypothesis. Following this, we make a decision based on the p-value. The p-value is the probability of obtaining a result at least as extreme as the one that was actually observed. Assuming that the null hypothesis is true, if the p-value is less than our significance level, we reject the null hypothesis. If not, we fail to reject it. Finally, we interpret the results. This is where we deliver the verdict. Remember, rejecting the null hypothesis does not prove the alternative hypothesis. It simply suggests that the evidence was strong enough to support it. So, to recap, hypothesis testing involves stating the hypotheses, deciding the significance level, collecting and analyzing data, making a decision based on the p-value, and interpreting the results. It's a systematic way of using data to answer questions and make decisions. However, it's worth noting that hypothesis testing is not foolproof. There's always a chance of making errors. The test's sensitivity to these errors depends on the sample size, the effect size, and the chosen significance level. It's also important to remember that correlation does not imply causation. Just because we find a relationship between variables does not mean one causes the other. Output. In the vast expanse of scientific research, hypothesis testing serves as a compass, guiding researchers through seas of data towards islands of knowledge. It's a tool, a method, a systematic way of putting our assumptions to the test. And while it might not always give us the answers we want, it invariably takes us one step closer to the truth. So the next time you find yourself standing on the edge of a scientific mystery, remember, the power to discover the truth is just a hypothesis test away.